Good day, viewers. A big welcome to you again. Today, we are on the next episode of the MACC Mathematics, and this is concentrated on indices. And this is our first question, which is question 1. 2401 is equal to 1 over 7 raised to the power 2x. This is our question. So, we have to tackle this question. But first of all, if you want to be able to solve this question, you have to do something by paying a keen attention to whatever I teach, or by looking at what I'll teach closely. So just in case if you don't know how to figure this out, watch out and learn the step-by-step procedure. First of all, do division. So you have to divide the 2401 by the 7. You will see that it will be possible for the 7 to divide this 2401. By dividing, we take it one after the other. 7 to 24 is 3. Remainder 3. I'll add the 0 between the 4 and the 1 to the 3 to become 30. 7 to 30 is 4 because 7 4 28. Now 28, 30 minus 28 is 2. So I have the 2 here. But I have to attach that to 1. 2401, that to 1, this one to the 2 to become 21. And now 7 must go into 21. 7 3 21. I can clearly see that 7 by 343 will give me the same answer as 2401. But this is indices. We want base and we want powers. So the main aim of what I'm doing is that I want to get everything like 7. I want to make the 2401 to become 7. So this is the procedure. This is the method. This is how I want to make the 2401 to become 7. By multiplying 49 by 7, I'll get 343. But we know that 49 is also 7 times 7, right? It means that I can make everything 7. But the 7 itself is called base. And that 2 there is called the power. So 49 can be written as 7 times 7 because 7 times 7 is 49. But since I have two 7s, we have powers there. The power is 7 raised to the power 1 by 7 raised to the power 1. In examination, they assume that you know that it is raised to the power 1, so they don't write that power 1. So 1 plus 1 is 2. That is why it is 7 squared. So anytime the base multiply, the same base multiply, we just add the powers. It is a rule. So we can clearly see that everything is multiplying. 7 raised to the power 2 by 7 by 7. But since this 7 is having power 1, we will just neglect the 7. We will just write one of the base, and we add the powers. So 7 is 7 raised to the power 1. So we need the power. So 2 plus 1 plus 1. 2 plus 1 is 3, plus 1 is 4. Therefore, 2401 is the same as 7 raised to the power 4. I now have the audacity to place 7 raised to the power 4 in 2401. And to be a man 2401 be ano, metro 7 raised to the power 4. Obey 7 raised to the power 4 and 7 raised to the power 2 as necessary because the bases are the same. The bases in the base na 7 no. 7 is that base. Into 7 raised to the power 4, replacing that 2401. Media replacement. Now it is equal to 1 over 7 raised to the power 2s. Bear it in mind that power in 4 no, and a 7 if in the base no. And it's a 7 in kwa ejina hono ma a 7 raised to the power 1 but intro. We assume you know obi anim so unim de da. So 7 raised to the power 4 is equal to 1 over 7 raised to the power 2x. A percent chance 7 raised to the power 4 no, and no 1 over 7 raised to the power 2x. Now we have to find that x, but that is the division sign into the negative ashawanum. My main can this is very necessary. The division sign stands for negative power. So 7 negative power 2x. The 1 over becomes negative. And the 2x comes there. So metro 7 now. I write the division sign. But since I want to make it in powers, the division sign will tend to negative power. And I'll attach my 2s to it. So 7 raised to the power 4 is the same as 7 raised to the power negative 2x. It means that x is some number. And if I multiply the negative 2 by s, I have to get 4. So same base. So I'll neglect the 7 and I'll deal with the powers. So if I have the same base, more base in the paper 7, I mean draw 7. No? I need the powers 4 and negative 2x. So I can say that 4 is equal to negative 2x. Now this is simple to solve. Anyone can solve this. This is a solve way. You see, the first thing to do is that someone can just divide through like this. So 2 goes into 4 2 times, but the best way is to divide both sides by negative 2. Here, there's some problem. My artificial intelligence just failed me, so I am only able to cancel the 2 by 2. I don't know how to put this, but this 4 equals negative 2s. So I divided the both sides by negative 2. And Nanka was negative 2 cancel negative 2. But you can clearly see that negative 2x, that negative wasn't able to cancel the negative 2, the denominator down there. So I can say that let it cancel. So it has cancelled. I cancel. So negative 2 cancel negative 2. So it is 4 over negative 2. And it will be negative 2 over 1. Negative 2 over 1 is the same as negative 2. So that is the answer for x. Question 2. We have 5a raised to the power 3 plus 2a raised to the power 3 minus 3a raised to the power 3 equals 32. Now, just in case you've never seen this before, the sign, that sign like I don't know how to call this sign, but it's like a triangular sign like that. A triangle without any base. Yeah, it is called exponent. So that sign means it is exponent. So 5a exponent 3 plus 2a exponent 3 will give me 7a exponent 3 minus 3a exponent 3. So I'm repeating this sign, I'm talking about this sign. It is the power. So 7a raised to the power 3 minus 3a raised to the power 3. 7 minus 3 is 4. So it will be 4a raised to the power 3 equals 32. We have to find a. Yes, we have to find a. So we can divide both sides by 4. We have to divide both sides by 4. So that 4 will take away 4. And a raised to the power 3 is equal to 8. Why? 4 goes into 32 8 times. 4 8 32 or 8 4 32. So we can see that 8 can be broken down into 2 because 2 times 2 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. So 2 that multiply itself 3 times will give me 8. As I've said earlier, the 2 is called the base. So every base is having power, especially these two standards having power, which is 1 or exponent 1. But we don't write, they assume you know. So whenever you have the same base multiplying, we have to write only one base and add the powers. So it is 2 raised to the power 3. Since the powers are equal, a is equal to 2 because it is a raised to the power 3 and 2 raised to the power 3. So equal exponents or equal powers, then the bases are the same. It means that a is the same as 2 or a is equal to 2. Let's try the next question. Now question 3. We are given this 2, which is 64 times 8 into bracket divided by 8 raised to the power 2. Solution. What kind of handwriting is this? I think this is looking horrible. Let me clean it and let me write the solution well. The first one was looking horrible. This is my solution, so I think this okay. I can split 64 into 2. 8 times 8 or 8 by 8 is 64. Multiplying another 8. So I close the bracket. This is my division sign. I write it like this, like a bar or over sign. It is the same as division. And I write my 8 raised to the power 2. Now I'm having 3 8. The bases are the same, so I write only 1 8. Then I'll add the powers. The powers is 1 plus 1 plus 1. Because whenever it multiplies, we just add the powers. So 8 raised to the power 3 all over 8 raised to the power 2. So bear in mind that when we have the same base, we have to add out the exponent. So if we have the same base and the base are multiplying, we just have to add the exponent. So it is 8 raised to the power 3 all over 8 raised to the power 2. So we can't cancel out. This is indices. So we can't cancel out or we can't do what we want. We have to use the indices rule. So if you don't know what to do, just watch it. I think you may be confused, but look at how I'll deal with this. I'll tackle this. So first of all, I write 1 8. I'm writing 1 8. Why? Because the bases are the same. I'm having 2 8. Then I write my 3. Then the division sign will change to negative power or negative exponent. I think I've mentioned this earlier or previously. So it is 8 raised to the power 3. The division sign will be negative exponent. Then I will attach that power 2 to it. And it is 8 raised to the power 3 minus 2. And 3 minus 2 is 1, but we don't write 1, so it is 8. 8 raised to the power 1 is the same as 8. This is question 4. And this is looking like word problem. We are still solving more questions. The square of 4 is multiplied by 8 to the power negative 2. And the result is divided by 16 to the index 2. Simplify the given problem using indices. Whenever they give you word problem, you have to understand it. The square of 4 is the same as 4 square. So I've written that. And the 4 square is multiplied by 8 to the power negative 2. And this is my 8 to the power negative 2. The result, meaning everything, is divided by 16 to the index 2. And index is the same as exponent or power. So the result is divided by 16 to the power 2 or 16 to the index 2. So wherever you see the term index, it is referring to power or exponent. And we are to simplify the given problem using indices. Up to now, you have to know that 8 raised to the power negative 2 is the same as 1 over 8 raised to the power 2. So 4 squared times 1 over 8 raised to the power negative 2. The negative exponent becomes the division sign, and the 2 remain as the power. And the result is divided by 16 squared. And 16 is the same as 4 times 4. So we can even change this 16 and write 4 times 4 all square. The 4 times 4 represents 16. We have 2 4s, so I can write 4 square instead of 4 times 4. The 4 is the base, the 2 is the power. As a result of the whole of 4 square times 1 over 8 raised to the power 2 dividing 16 square, I have to put it into brackets. Yeah, I will say you change 16 square no, and then 4 square all square. And change 4 square times 1 over 8 square no. A bare 4 square times 1 a 4 square over 8 raised to the power 2. Now 8 a 4 times 2. And to baby I'm 8 be an 4 times 2. Now the square no is affecting everything, which is the 4 and the 2. So 4 square by 2 square equals 4 square times 4, because 2 square is 4. If the law is still in memory, you will realize that we write one of the base because the bases are the same, then we add the powers. So I write one of the 4, and 2 plus 1 is 3. So 4 raised to the power 3. Yɛde work na bɛdu ne sei no, wɔbɛhu sɛ base no nyinaa ɛyɛ 4. So ɛbɛyɛ easy koraa sɛ yɛbɛwie work no. The right thing to do is that you have to change the division sign to product sign or multiplication sign. If you followed me for a long time or some time, you will see say I always say any number be over 1, but you enter over 1 no. But whenever you change the division sign to multiplication, the one which is the denominator will be the numerator, and the numerator will be the denominator. And then they are changing, no? But the powers will multiply, so 2 by 2 is 4. So we have 1 over 4 raised to the power 4. And there is the point we call work done. Yeah, so 4 squared times 1 is the same as 4 squared, all over 4 raised to the power 3 times 4 raised to the power 4. We write only 1 4 because they are same base. Do you remember? We add the powers. 3 plus 4 is 7. So this is it. But remember that 4 and 4 are also the same. So same base are dividing. We have to write only one base, then 4 raised to the power 2. The division sign will become negative exponent, so minus, and then we attach the 7, and 2 minus 7 is minus 5. Now, work done. But someone can also rewrite this as 1 over 4 raised to the power 5. 4 raised to the power 5 can also be written as 4 times 4 times 4 times 4 times 4, meaning 4 multiplying itself 5 times. And 4 multiplying itself 5 times, or 4 raised to the power 5, is 1024. So 1 over 4 all raised to the power 5 is the same as 1 over 1024. 1 over 4 raised to the power 5 is 1 over 1024. This is the end of the questions. Please subscribe to this YouTube channel. Share the link of the video to others. I want to know your comments in the comment section. Thank you very much for being with me on this channel.